do some area now. So we've seen area. Area is squared. Volume. You may guess if area is squared, volume is going to be a cubed relationship. So I'm going to attempt to draw in some cubes. We'll see how it goes. I draw a small cube, a bigger cube, and a bigger cube still. And I'm going to separate this up and make it kind of 3D-ish, hopefully. That's not too poor. I didn't do particularly well in my GCSE art, so apologies in advance. I was too busy doing maths. All right, I think we're there. So as we can see, we're kind of making our bigger cubes out of kind of multiples of our smaller cubes, right? We're kind of combining this base cube that we've got over here, and we're kind of making bigger and bigger cubes, kind of like Rubik's cubes in a way. So if we, I'll just make that 3D as well, just to finish it off. If we wanted to kind of calculate what's going on with the volume now, well, I want to make it super easy for myself. And I'm going to say this is a 1 centimeter by 1 centimeter by 1 centimeter cube. And so obviously the volume of my cube is going to be base times height times depth. 1 times 1 times 1 gives me a volume of 1. And the units, because I'm doing centimeters times centimeters times centimeters, are going to be centimeters cubed this time. And we could do a similar thing again for our larger cube. So my linear scale factor, right, is going to be a scale factor of 2, isn't it? Because I've now got a kind of base of 2, a depth of 2, and a height of 2. So I'm kind of multiplying my original cube by a scale factor, a linear scale factor of 2. And there's kind of 2 ways we could calculate this. We can use our standard formula, which is base times depth times height. 2 times 2 times 2 will give us 2 times 2 is 4, times 2 is 8. So that's one way I can get my volume of 8 centimeters cubed. The other way is we could just literally count the cubes, right? How many lots of 1 centimeter cubed cubes do we have? Well, we've got 1, 2, 3, 4 in the first layer, and we've got another 1, 2, 3, and there's one kind of at the back there, or in our second layer. So again, we've got kind of 8 of our mini cubes to make our larger cube. And that's why I've kind of divided these up into smaller cubes to kind of make that clear. We could do the same thing again and look at our even larger cube. Well, we're now going from a linear scale of 1 by 1 by 1 to a linear scale of 3 centimeters by 3 centimeters by 3 centimeters. So our linear scale factor is going to be 3x, isn't it? So we could do both methods just to make it super clear. Our volume of our largest cube is going to be base times depth times, or kind of width times depth times height. And that's going to be 3 times 3 is 9, times 3 is 27. And again, those units are centimeters cubed. The other way we could do it, if anyone was super lazy and they forgot the formula for the volume of a cube, we could just count how many little cubes we have, right? Because each one of these little cubes, as I said before, is a kind of 1 centimeter cube. So, I could pick a random cube on the corner here. This has a volume of 1 centimeters cubed, right? So however many of these little cubes we have is going to tell us what the volume of my large cube is. And we've got kind of 3 by 3 in this first layer. So all these cubes here in this kind of front layer, these have a volume of 9. get rid of that. It's a volume of 9. We've got 9 cubes in our first layer. We've got 9 in our second layer, 9 in our third layer. So we've got 27 small cubes in total. So that kind of that's another way of thinking about how our volume is actually being calculated. And as you may already have spotted, as we increase our linear scale factor, as it goes from 1 to 2 to 3, our volume scale is, well, obviously it's 1 for our first cube, and then when we have our linear scale factor of 2, our volume scale factor then becomes 8. We have that 8 there, and for a 3x linear scale factor, we end up with a 27 centimeter cubed volume. So we're going from a 1 centimeter cubed for our small cube up to a 27 centimeter cubed for our larger cube. And hopefully you can spot the pattern. If I was to fill in another one, if we imagined a much larger cube off the screen over here, some of you might be able to instantly tell me what the volume of that cube would be. These are all, these are all our cubic numbers. So just like we had square numbers before, these are our cubic numbers. And 4 cubes is going to be 4 times 4, 16, times 4 is 64. It's always good to have a few cubic numbers in the back of your mind. And I could do one more. 5 cubed is going to give me 125. And we can see, right, it kind of makes sense why we're getting cubic numbers here, because we're literally taking our scale factor of 2, and that's giving us our length of 2, and also our width of 2, or our depth of 2, and our height of 2. And we're doing 2 times 2 times 2 to get our volume. So we're literally doing 2 cubed to get our volume. And same thing again, we've got our linear scale factor of 3. That gives us a kind of width and depth and a height of 3. We do 3 times 3 times 3 to get a volume. So that's why we end up with these this kind of a series of cubic numbers.
A few moments later.
Thanks for that, Ollie. Really appreciate it. I'm sure people got quite a lot out of that, and we're going to see if we can break it down into those individual questions as well. So if people come across them like that as well, hi. If you're looking to get a tutoring session with Ollie, he is free. He is available for sessions just like this. You can catch his profile in the link below, and clicking on that will take you straight to his Sherpa profile. From there, you'll be able to get in touch with him and organise some tuition sessions. If you're looking for an English tutor or a science tutor, then again, head onto the Sherpa website. We've got thousands of tutors there ready and available for you to have some sessions with. And if you're unsure and you need a bit of help, get in touch with our tutor experts, 01628 337 590. We'd be happy to help you out. But yeah, thanks again, Ollie. Really appreciate it. And see everyone later.